So the tuning process. So basically, the best way to approach it is to grab a backup of your production systems. So you will have a point in time state of your data, which you can then go back to, restore it on a host, some testing host. Ideally, this host will be using the same hardware as production, again, to make it more relevant to production. And then capture real-world queries, yes, using slow dump, slow lock or TCP dump. And actually, it's a step that I didn't put here, but also, I mean, you obviously want to have some kind of baseline. So you should first run the process, run the benchmark against the current settings, your current configuration, and see and calculate the performance, like maybe how long the whole query mix has been executed, how long it takes for it to execute. And then you want to make one change at a time, one change in MyCNF or OS settings. Restart MySQL or reboot even the host itself. The idea is just you want to start from the same state, the same position all the time. So you don't want to. I mean, if you like to warm up your system, that's fine, but you have to do it in exactly the same way. So you make sure that the data is in buffer pool in exactly the same order, in exactly the same way. And then replay this traffic using, I don't know, maybe Percona playback or PT upgrade or some other tools, scripts that you put together for this particular purpose. Measure the difference comparing it to the baseline, and then if you want to do some other tweaking, repeat the process by restoring the backup again, right, to this known state. Again, make one more change, so in your MySQL settings, again, warm up the host as you like to, but make sure it's the consistent process. And rinse and repeat until you're happy with your MySQL configuration or OS settings. So tuning the OS, the operating system for MySQL. Obviously, this is an important bit because MySQL runs on some kind of operating system, so it is affected by some settings. There are like two main things that you'll be looking into when talking about operating system. So first of all, it's memory. Basically, one of the variables that you will be, the settings that you'll be looking into are the setting which governs how operating system flushes its disk cache. So I'm talking about VM dirty ratio and the VM dirty background ratio here. So basically, what our goal is to minimize the flushing operations in operating system, just to ensure that there are no stalls happening for too long when the dirty data is flushed to disk. So basically, the VM dirty ratio is hard limit of the memory that can be used to cache dirty pages. VM dirty background ratio is the percentage of memory that can be used to cache modified dirty pages before the background process kicks in. In general, we want those settings to be in low numbers, like 5–10% of your total memory. This is because we want to trigger the flushing often and make this flushing quick. So less memory means that we will be running this. The flushing will be triggered more often, and basically the amount of data to store to disk will not be that big. Of course, default settings may vary between distributions, but some of them have settings like 40, those variables set to like 40% of your total available memory, for example. So this may be a problem if you have a large instance. You have 128 gigabytes of memory, for example. It theoretically means that at some point your system may decide to flush like 50 gigabytes of data to disk. And this is a lot even for quick SSD storage. So you want to we want to avoid it. Of course, again, everything depends on your configuration, on your MySQL configuration in this case. Because if you, for example, use flashing method in a DB as direct, then your data won't end up in operating system cache, right? But still, there may be some other processes, maybe some other files that will be stored and eventually will be flashed to disk again. So those settings are pretty important to keep in mind. Swapping obviously is a process of moving data from memory to disk when the data, when the memory has to be freed for some other more important information. MySQL obviously does not like active swapping because if we configure it with buffers of a given size, we want the data to stay in memory, right? Not on disk. But even more, we don't like to MySQL to be killed when the system runs out of memory and the OM killer cuts on the killing spree. So what we want to do is we want to allow some swapping if it is the only way to actually keep the system up. And you can achieve it, but by setting VM swapping as equal to 1. And in the past, you may, in the internet, you may see that suggestions to set VM swapping as to 0, which was an okay setting for old kernels, but starting from 3.5. That just means that there is no swapping at all, which obviously is dangerous. So you want to set this setting to 1, just to allow a little bit of swapping if that's the only reason, the only way to keep MySQL up. You can also deprioritize MySQL for OM killer, so it would be less likely to pick it and kill by running this echo command, and the PID is a PID of MySQL, of course. Thing is that this may help. It may help when you have some kind of shared environment like MySQL and some other processes running. But if your host is MySQL only, and MySQL is responsible for over allocation of the memory, this may not really help much. So yeah, but swappiness should allow you to run the host a little while longer, just to make sure that basically you shut down MySQL correctly and it won't get killed. So if you're running MySQL on a dedicated host on physical hardware, you want to also make sure that you have numerical leaf policy set correctly. So starting from 5.6.27 in MySQL, there is a variable called DB numerical leaf, which can handle it for you. Otherwise, you can change your init scripts to start MySQL using numa ctl interleaf command. Basically, if you're running on the virtual instances, most likely you won't have to be bothered with this because it will be handled on a higher level for you. But if you're running basically on the hardware, then yeah, this is. Of course, especially if you have multi-socket motherboards, so this is pretty important. Other things you may want to look into when it comes to memory and operating system is the memory allocation library, which may impact the performance of MySQL. So there are a couple of choices. By default, it's glibc malloc, but also there is a tcmalloc, there is jmalloc, and probably a couple of others. But those three are the most common picks. You can either use ld preload to load the library, or you can use malloc -lib variable in MySQL safe section of MyCNR. to tell MySQL which library should be used to allocate memory. And here is a result of a benchmark that I did on an EC2 and using sysbench read-only in-memory workload. So we have like default malloc is on blue, which is hardly visible because it's basically the same on the same level as a JA malloc. But as you can see, the TC malloc, for example, gives you a lower performance. And this is not. I mean, you might think that, well, I mean, why bother when the default is running okay? But it's just one single type of workload. In your case, it may be completely different. So the point of this graph is just to show you that there are differences between different types of memory allocators, and it may look different in your case. So you want to benchmark. And the I/O. So the main thing that you'll be looking into are disk schedulers on the operating system. So some of the distributions comes with CFQ scheduler, which is tuned for desktop workloads and may not work as great as for the database server. Usually NOP or Deadline are better for MySQL, and basically you have to benchmark to see which one works better in your particular case. Theoretically speaking, I've seen NOP being works slightly better for when you run on some smart large storage area networks. In which case it might be that your storage area network controller will, it will be better. It will know better how to flush the data, how to write the data, instead of the OS. So for some RIs you may see not performs better, but in general benchmark it, just because it depends on hardware, depends on type of the storage. In cloud it may look completely different. Actually, I did some benchmarks, and basically on EC2 instance with provisioned IOPS, I haven't seen any difference between neither of them. But again, your needs may vary. And also file system. So most often you'll be using either ext4 or XFS for MySQL. Performance differs between them, and the thing is the difference, it depends on the workload, hardware, and kernel version. Because I've seen, it was like, first of all, the XFS was the choice, like almost by default, and then the XFS, the ext4 was improved in some kernel, and then it became to be the better option, and then again XFS was improved, so on and so forth. So depending on your kernel, depending on your hardware, it might go one way or another. So benchmark to see what works better for your environment.